Alright, here we are at lesson 203, surface area and volume of prisms, part 1. And I noticed some of my students are doing great at adding their course number and their section number with all communication to me. Oh, that makes it so much easier to help you. So those of you who aren't doing it, get on the ball and get her done. Not much objectives in this lesson. We're going to develop and use the formula for surface area of a right prism. Some of the terms that we'll be talking about today are altitude, base area of a prism, bases of a prism, height of a prism, lateral area, and lateral face. These terms aren't really that new because I think we covered a lot of them in Unit 1. Okay, if we look here, we've got the surface area of right prisms. And what I did was took these right prisms. I've got a rectangular prism. Let me get my pointer. I like my pointer. I like it a lot. This is a rectangular prism that I've laid out as a net. This is a triangular prism that I've laid out as a net. And notice I've labeled lateral faces and I've got arrows pointing to the lateral faces. Okay, these are bases. The two that aren't included, those are bases. And over here, and so that's why it's a rectangular prism, because the bases are rectangles. And then over here I've got triangles. Okay, those are my bases of my triangular prism. And notice they're not included as lateral faces. So what I want you to notice is that for both of these right prisms, when the lateral faces are lying side by side in the net, they form one large rectangle. So check this out. Dun dun dun! There we go. I highlighted the rectangle in yellow. Okay? And so if I'm wanting to find the, well, I'm going to get ahead of myself. So let me stop. Okay. Looky here. I've pointed here, labeled the perimeter of the base. This yellow line represents the perimeter of the base for both of the right prisms. Okay? The height of the prism, notice right here, this is the height of the prism. Here's the height of the prism. Okay? What I like to refer to as the height when I'm actually seeing these, not as a net but as a solid, I like to tell you that the height is always that line that connects the bases. See this line right here? I like to call that my height, which is the same exact as this line. Alright, and over here in the triangular prism, here's my line that connects the bases. And it's going to be the same size as this line. Any four of these lines, 1, 2, 3, 4, you could call any one of those your height. Just like you could over here. This is the height, the height, the height, the height, the height. Okay? This here is the formula we have been using to calculate the the total surface area. Okay? It tells us to find the sum of the areas of all the lateral faces, and here they are. And then to add that to the area of the base times 2, because there's two bases. Check this out. The new and improved formula. Okay, that's what we got going here. So, notice how they've replaced this L with HP. And guess what? Here's H, the height of the prism, and here's P, the perimeter of the base. And you know what? I said that is the perimeter of the base. I know it's kind of confusing because this right here is the base. Okay? But what I'm trying to hoping to help you see is that this yellow line from this point to this point is the perimeter. Because if I folded this up and made it a solid again, this section would be right here. Okay? This section represents this top part of the base. And then this little short side over here, wait, no, right here. Sorry, there was two short sides. This short side right here represents this side of the base. So, and of course this is lying on the side that it represents. So if I got the measure of this line right here, I know what the perimeter of the base is. Okay? I hope that's clear. And it all works the same with this triangular prism. This line represents the side of the triangle that it's on. This section right here that I'm pointing to represents this side of the triangle. This section right here represents this side of the triangle. So if I figure out what is the measure of this line right here, I know what the perimeter of the triangle is. I like how that works out, and it makes our work less, so we're not having to do as much calculating. Okay, so let's go through some examples. Examples are always nice. Notice here's our new formula. S equals HP plus 2B. Okay? Remember, H is the height of the prism. It's the edge that connects the bases. Here's P, capital P, for the perimeter of the base. I believe in this object, this right here is my base. This top that I'm looking at right here is going to be my base. So my height is going to be this line right here. See how it connects the bases? And then I'm going to figure out the perimeter of the base. Okay? So let's find the perimeter of the base first. Holy cow, I put everything in there at once. Okay, capital P equals 2 times the width plus 2 times the length. Okay, I bet y'all been learning that formula for a long time. That's the formula for the perimeter of a rectangle. So look here, they're taking the width of the base, which is right down here. They're using this, 5. The length of the base is 4, and they're plugging that in. So when you say 2 times 5 plus 2 times 4, you're going to get 18. So the perimeter of the base is 18 kilometers. Okay, now we're going to find the area of the base. So see, we found capital P. Here's capital P. We're going to plug it into the formula eventually, right there. So now we're finding the capital B, the area of the base. See if I splashed all this up at once. No, I didn't. Yay. Okay, so to find the area of the base is a rectangle, so it's going to be length times width. Some of you may know it as little b times little h, base times height. So my length, they've already told me, is 5. My width is 4, so I'm going to plug those numbers in. And I get 4 times 5 is 20. So the area is going to be 20 kilometers squared. That's supposed to be a little too. So when I get to my formula, I'm plugging 18 in for capital P. I'm plugging 20 in for capital B. Now I've got to find the H, and I've already identified that as the portion that connects the two bases, which is 9 kilometers. So let's plug into the formula. Find the surface area of the prism. You've got little h, capital P, capital B that you've got to fill in for. So I've got 9 for my height, 18 for capital P, 20 for capital B. I plug all of that into my handy dandy calculator, and it should shoot me an answer that says 202. So my surface area is going to be 202 kilometers squared. Okay? So anytime you're finding the surface area of a solid, you're going to have a formula. You're going to have variables in that formula that you need to get information for. H was the easiest one because it was given. Okay? But I had to calculate the capital P and I had to calculate the capital B in order to find the surface area. Let's look at another example. A right prism has a regular hexagon as a base. The area of the base is 260 square meters, and the apothem is 8.66 meters long. If the surface area of the prism is 1,000 square meters, what is the height of the prism? So in this one, they've given us the area. They give us a little information about the apothem, which I'll explain more in a moment. They tell me the area of the base, and they tell me the surface area of the prism, and they want me to find the height. So I'm still going to be using a formula for finding the surface area, except there's a new variable I'm looking for, and it's going to be the height. I always like to draw a figure, and of course I didn't draw this, I just went and copied it off Google. Now here's your apothem. I believe I've explained this in earlier lessons, and I will be putting a geometry formula chart in Doc Sharing later this afternoon, so you'll know how to find or know which formulas to use. But here is the apothem. It is always perpendicular to a base, to an edge, and it goes to the center of the base. That's your apothem. Okay? So, first, we've got to find the perimeter of the base, because that wasn't given to us up here in the problem. So, here is the formula for finding the base area of any polygon. It doesn't have to just be hexagons. It can be a pentagon, octagon. This is the formula that you're going to use to find the base area. The little a stands for apothem, and the capital P stands for perimeter. Well, we need to find the perimeter. So I plug in, they gave me the apothem is 8.66, so I plug that in for the little a. And remember, I'm solving for P, the perimeter. So let's see what we do next. We're going to go ahead and take half of 8.66, which gives us 4.33. Then I'm going to divide both sides by 4.33. And I get approximately 60. Notice I went from an equal sign to an approximation sign. That's because it probably had ugly decimals. So my perimeter is approximately 60 of this hexagon. So this hexagon has a perimeter of 60. So now I'm going to use all this information they gave me in the problem and the perimeter that I just found to find the height of the prism. Remember our new formula? Surface area equals height times perimeter plus 2 times the base. Okay, so I've got to find h. I figured out what my perimeter was, and they gave me the area of the base right up here. They told me it was 260. So I'm going to plug those numbers in. See, they told me the area of the surface area of the prism was 1,000, so I plug that in for S. Oh, I still have to use my approximate symbol because I'm using 60 for the perimeter, which was an approximation. I don't know my height, and I plugged in the area of the base of 260. So I went ahead and simplified 2 multiplied by 260 and got 520. Now I'm going to subtract that 520 from both sides. I get 480 is approximately 60h. Remember, I'm looking for h, so I'm going to have to divide both sides by 60. 480 divided by 60 gives me 8. So 8 units is, or I guess it'd be meters. 8 meters is the approximate height of the prism. Okay, what we talked about in this lesson is the surface area S of a right prism is the sum of the lateral area L and the area of the two bases. That's the old formula we were using. And what we're doing now is replacing that L with the height and the perimeter of the base of the prism. And it's kind of like we just took a shortcut. We found an easier way to work out this problem. And I highly suggest you go to the problem sets and do some practice, because that's what it takes to get this down. Practice, practice, practice.